not many questions.
Yeah. There's only one of this in the long pad. Okay. Don't worry, okay, I try to find some for you. Or maybe some school may have. But anyways, in EMATS, okay, you will still have it. When they teach matrix time, you still have a lot of questions.
But the EMATS textbook don't have a chapter on matrix.
Don't have chapters on matrix, right? Huh? No, that's the old EMATS textbook.
The new one.
New one.
The latest.
Don't have.
So EMATS don't have, AMATS don't have, then we are happy with it.
Then we still learn for what?
I don't know. Okay, A-level
But
we
this
did
one
it.
A have what?
No, no. The history is like that here. Matrix belongs to EMATS all along. Okay? And suddenly appear in AMATS, and then disappear from EMATS, and then they disappear from AMATS, they want to put it back in EMATS. So now is it in the between? I don't know. keep throwing here and there. But matrix is actually very important. I don't know why, okay? But even A-level you still need to use it. Okay? So anyway, if that's the case, that I leave there's only one question here, okay? So this is a golden question. I want to leave it to you to try yourself. Number 5, okay, go home and try yourself. You might not be able to do it, that's what my expectation. I expect you not able to do it, okay?
Okay.
So do the last 2 questions on AMATS. I expect you can do that 2 questions.
Question 5, do question 5.
Yeah. There's only 1 question, okay? If it over also no more.
One question got I, B, C, I.
Okay, let's come to log. And
Logarithm.
logarithm. Okay, now when we talk about logarithm at time, right, we need to know
Yep.
indexes.
Yep.
Do we need to go through indexes? Do we need indexes help?
Yes,
for
yes,
index?
EMATS have.
Do you have any problem with indexes?
I read now. Try lah.
Okay, let's try it again. Then just remember the yellow box. Anything to understand? You don't need me to go through it?
Yes, you need.
Okay, fine.
Yellow box.
Yeah, all these things.
This is green.
This is indexes for what? Surd indexes on the logarithm.
The other day you were asking me what's an integer.
What's an integer? Integer is
Whole number.
integer equal to whole number.
No.
Yes.
No.
What's the diff? What is the integer which
Whole
is not
number is
whole
whole
number?
number, integer, integer.
Tell me what's the so give me
I
an
don't
example.
know. I think it's different.
Then I tell you it's the same.
Okay, good.
Okay?
Hey.
Good. Okay.
Whole
The
number.
reason is that you can't find any integer which is not a whole number. You can't find any whole number which is integer. So logically they are the same.
Okay.
No, they are not the same. They are equivalent.
Okay.
Because the spelling is still different,
Okay.
right? Okay, good. So, so, okay, we have in the number world. Okay, they will finish the things here. You have natural number. You have integer.
You
Okay.
have phone number, you have decimals, you
No,
have fractions.
these are the set. Okay.
Okay.
They are different, so this is why we're going to mention. Say, third one is a rational number. The fourth one is an irrational number.
Mm-hmm.
The fifth one is a complex number.
Mm-hmm.
Okay. Natural number is inside integers. Integers is inside rational number. Rational number is inside irrational number. Irrational number is inside complex number.
Okay.
Okay. Complex number. Irrational number we use a C. Rational number we use R. Okay, sometimes we call it a real number.
Got fake one meh?
Oh, sorry, irrational number and real number are sorry. This irrational number and rational number are called real number, right? Why control? This is wrong. Okay, the biggest one is called complex number. Okay, complex number. That means those are real and virtual number also there. So inside here we have nearly half of the word called real number. Okay. So there's something called which is not real number. For example, square root of -3.
2i.
Yes, this is square root 3i.
Oh, 3i.
So square root 4 minus 4
Square root.
minus 4 square root, right, is actually square root 4 times square root minus 1. So it's actually square root 4 dot I, so therefore it is 2i.
2i.
Okay, so this is called imaginary. This is why all of this is called complex number, but only part of it, right, is called a real number. Real number is all our number that you learn in Sec 4. You will learn anything. You will not learn anything outside the real number. Okay, in real number here is further partitioned to 2, and one is called rational number.
It's called irrational number.
Yeah, irrational number. Okay, now so how do we define rational number?
No decimal.
Not really. Okay? Rational number is anything that can be represented by a fraction. Okay, 7/3 you press the calculator, give you lots of decimals also.
Okay.
But this is a rational number, okay, because it can be presented by a fraction. Okay, irrational number is something that you cannot present by a fraction. Okay, now even the integer can be presented by a fraction because 4/1 is still a fraction. Okay, so even this kind of thing is a rational number. So irrational number is like square root 3, okay, pi, or e to the power 1.
E?
Yep, press the calculator, you see an e there.
Where got E?
Look, use your eyes. In front of you, use your finger to press.
E.
Yeah.
Okay, set alpha E.
Can.
To the
All this number, right, cannot be presented by fraction. Okay? So therefore they are called irrational number. Okay, so do not think that you have decimal and you have irregular decimal.
E is number, man.
E is a number. Go to wiki the E, okay? It is a number. Is pi a number?
Okay, it's a number.
Okay, fine. E is something like pi, okay? It's actually a specific number, but we normally thought, let's say it's an E, okay? So if you want to check the value of E, how to get it? Use your calculator, E to the power 1.
Where got 1? I cannot power 1, what? How to power 1?
E to the power 1 is not E.
E to the power 1 is E. So that will tell you the number from the calculator.
Where got power to 1 1? Only got power of 2, power of 3.
E war. The calculator so special. This is E, right? Inside the ln is E.
This? Oh,
Yeah,
okay.
okay. Not the EXP, okay?
So
Don't
function
press that
E
That
equals
E is not.
1. Oh, 2.7182.
Yes, 2.7182, that one is the value of E. Okay, so this is something like pi, which cannot be presented by
Pi can, oh yeah,
pi cannot. Nowadays they're still adding the digit behind what? There's a computer in the world that keep adding the digit behind.
3.142.
Yeah, it's still
3.143.14.
okay, forever okay. Go to wiki pi. They give you lots of numbers.
Really, man?
Try it.
3.141.925.
No, the computer is still calculating, okay? You can keep going, okay? Anyway, so you know what's irrational number, what's rational number?
Yeah.
Okay, so you press 7/3 in the calculator, see the decimal?
7/3.
Yeah, press it. Press it. Now it's also a bunch of ugly numbers.
2.3.
Oh, that's not good. Okay, so 13/7. Okay. Try.
13/7. 1.857142857.
Yeah, you can see
Yeah.
okay, it seems to be keep going the decimal, right?
Infinity.
Okay. Now, so all this is not infinity is outside. It's not even in the complex number. Okay, don't respect the infinity, okay? Because other than infinity, what is the meaning of 10 to the power minus infinity? That means 1/10 to the power infinity. That means 1/infinity. It's infinitely small, but how small it is? It is still infinitely small, but very close to 0, but it's not 0. Okay, so don't always look up. Look down here, we also have infinity. We say we have 1 second, right? So what's the meaning of infinitely small 1 second? Then to the infinitely small 1 second, right, we are infinity. So are we living in a world of infinity? I don't know, okay? So don't play the kind of things, okay? So let's come back here, okay? Now real number, okay, so rational number here. Inside the rational number we have integer. Okay? Integer, which is the whole number, okay?
Yeah.
And inside the integers, right, we have natural number. Natural number is an integer start with 0. Okay, 0, 1, 2, 3, 4. This is called a rational number. Okay, so these are number system. Okay, so just for your knowledge. Okay, when we do surd, right, we have
that is on very dumb.
sorry? I thought you said you need to talk about surd and indices.
Yeah.
I want to fall asleep.
Okay.
Surd and indices. Okay, we have kind of things like square root 9, that kind of things. Okay. Okay, you need to know some perfect square. Okay, perfect square is 3. What is 1 to 1 square root? 169?
1 to 1, 11.
11.
169?
13.
Ah, good. Okay. So all those perfect square until 13, maybe you can remember it. Okay, so if I have let's just come with some questions. Okay, now surd, right, is actually how do we present an answer. Okay, if it is 18, okay, we cannot give this as an answer. We got to make it a surd form. Okay, surd form is either surd form or decimal form or fraction form. So in this case, we're going to break it down. Got see inside got any complete perfect square. Okay, the perfect square is 9. Okay. There's a perfect square inside, it's 9, 9 times 2 is 18, okay? So therefore the 9 you can do a distributive law, okay? Then it becomes 3 root 2, so this is the answer. Okay, this is what we call surd answer. Got it? So instead of giving square root 18, right, we'll give 3 root 2. That's the idea of surd.
Understand?
No.
Got it? Is it too simple so that you don't understand? You expect anything more than that? No, sorry, they're just talking about this.
Don't understand.
The idea is that if you have any perfect square,
18 is a perfect square, man.
no, 18 is not perfect square, but it has a perfect square of 9.
It's kind of reduced.
18 equal to 9 times 12, 9 times 2, right? So the 9 is a perfect square, right? 18 is not perfect square. So that's why I say it's not 18 is a perfect square, but 18 has a perfect square. 佢裏邊有個 perfect square.
Okay.
咁你就要 take it out,
Yes.
distribute both,
Okay.
and make the perfect square one an integer outside, which is
Okay.
this is the
Understand.
answer. Okay?
Yes.
So tell me, 24.
Square root of 12 and 2.
Okay. 12 and 2 for what? 2 is not perfect square, 12 is not perfect square.
Oh, okay, okay.
So what do you want to take?
8 and 4.
No.
4 and 6.
Uncle! Keep quiet, guy! Okay, 4 and 6, right? 4 is a perfect square, right? So what do you have? So you have?
2 square 6.
Yep, 2 root 6 is your answer, okay?
Simple, right?
乖啊
No hard.
乖唔該，我要佢諗啊。Okay. 27 square root, what do you have?
9 and 3.
So answer?
3 square root, 3 root 3.
Good, okay. 明啦 ，okay， 咁就 perfect square。wait， 呢個係 step 1 of surd form，okay。Now step 2 of surd form, the idea is that in the denominator, can this be answer? Yes. Okay, the idea is that denominator have no surd, no square root. Okay. If the denominator have a square root, for example, you have this. This cannot be an answer. It's not in surd form. Okay. The surd form says that denominator cannot have square root.
Okay.
So that you got to say this is the answer.
Huh?
The idea is to time the same thing so that this square root is gone. So you left 2
okay.
over 7 square root 7 on top. And make sure your square root is on top and there's nothing in denominator, then it will be a surd form. Okay? But in this case, right, most probably, right, you will use one of the identity very often.
Square the root, so the root is gone.
Yeah, okay. So the idea is this, you need to remember this a square minus b square equal to a plus b, a minus b.
I know.
Okay? But now you got to read on the other way around.
Oh.
Is that if you have a plus b,
Okay.
when I add a minus b, right, or when we time a minus b, you will have a square minus b square. What's the use of this? If you have kind of things like square root 3 plus 4, 7. Now, surd form means that I cannot have a surd in the denominator. So what must you do? Use this concept. Because whenever you introduce a minus b to a plus b, each one of them will get squared separately. Okay? If you're given a minus b here, you time a plus b, right? The a and the b, each one will be squared individually. So therefore, if this is your problem, you're going to do kind of things like, I introduce root 3 minus 4 for both from nowhere. Because if you have a plus b, you introduce a minus b, right? The individual number will get squared. So then the square root 3 will be gone. Okay, 3 minus 16. Then, of course, the issue will come to the numerator, but it's okay. Numerator can have
Not 3 square minus 16 square.
It is square root 3 square minus 4 square.
Oh, yeah.
So this is why it's 3 minus 16. Okay?
3 square minus 4 square. Oh,
Square
okay.
root and square, right?
Yeah, okay.
Oh, there your square root is gone. So
Three,
then
three.
this is kind of things like your answer is 7 root 3 minus 4, and then below you have minus 13. Okay? Then what's equal to 7 4 minus root 3 positive 13. Do you know this?
No.
Okay, the idea is that you have anywhere, okay, and if you have a minus sign somewhere, okay, you can
swap it over.
Yeah, or you can put it on top. So either one have a minus sign swap, minus sign, but positive sign cannot. Don't you?
Yes.
You're scaring me. Okay. Okay, you got what? Okay. Throw the minus sign up so that these two swap.
Both must swap.
Yeah. Okay.
X minus.
Can it swap or not?
Huh?
Can this one swap?
This one cannot. Cause it's.
It doesn't make sense, right? Okay, so you need the minus sign to swap. And they will absorb minus sign. Swapping the minus a minus b and b minus a, right? You require minus 1 in front. A swapping of a minus b to b minus a, okay, you will eat in 1 minus sign. Okay, that's for your memorizing. For understanding, you are not swapping. It actually says the positive go to negative, negative go positive for me. Okay, so actually this counting as swap, which will require minus 1. Okay, forget it. Okay, you don't need it.
嗰個下低嗰個唔可以索。
嗰下唔係 swap，因為你其實 absorb the minus 1, right? You have minus and minus, so it will never equal to this. Okay, so so-called swap is not really swapping. It's actually you say is that you say 2 minus x, right? Is actually make this is actually plus 2 minus x. If I put a minus 1 in front, okay, or just minus in front, right, the plus becomes a minus and the minus becomes plus. So it seems like as if it is 2 x minus 2, so it seems as if it is swap. Okay, so this to this, right, actually is time minus 1. This one understand? And this time minus 1 give you this.
Okay.
This time minus 1 give you this. Okay? 呢個得啦喎。Okay, so just remember this one. Okay. That one show up down. Okay. So this is what I say. if you have a minus sign, I don't want it. And throw to this guy.
Why not throw to 7?
It wouldn't be beautiful. You can throw to 7.
Minus 7, then after that.
Yeah.
3 plus 4.
So easily
3 plus 4.
Then like that won't 错 嘛.
This one also won't 错.
But 那个比较
No, this is what I want you to learn. I know you know minus 1 can
都是复杂.
But this is very handy, you must know. It's very handy. Because sometimes some questions is ugly, right? There's the minus 1 outside, you just absorb it, you'll be arranged and it will look nice. And once you look nice, right, none of this is negative. Okay? And that is negative.
Easy to calculate.
No, this is easier to calculate. Okay? The idea is that the best that in your whole equation don't have any minus sign at all. So if you get some way they can absorb away the minus sign, absorb it in a better way, okay? Whatever it is. And so now, so this is not a surd form yet. Because a surd form, right, it all consists of a non-square root component and square root component. So the actual things, right, you got to say is 7 times 4 divided by 13, okay, minus root 3 over 13. Okay, the non-square root component must take one side, and square root component must take one side. So the answer is actually 28 over 13 minus root 3 over 13. So this is the surd.
The 7, 7 times root 3.
7? Oh
The
yeah,
second one.
I missed out, sorry. Yeah, this is 7. Okay, 7 here. So 7 over 13 square root 3. So this is surd form. Okay, so this is surd. Okay, so surd is in your exercise 2.1.
Can try first.
Okay, try first. Fine. You need to do log.
The 28 over 13 can change it to 1 and 2
No,
and
no.
2/3.
Fourth fraction. Okay, put it in fourth fraction is preferred because there's a reason for it. But in your set 1, 2 they still ask you to change, but set 3, 4 the time they encourage not to change. The reason is, right, if you put it as 2
and 2
and
over 13.
2 over 13, right? This is confusion because when we don't put any operator inside, we assume a multiplications. Okay, but actually, right, whatever you don't put here, actually it means 2 plus 2 over 13. You have 2 plus 2 over 13, you make it better, you get back 28 over 13. So this immiscible things now is a plus, right? It's against our norm. So this is why they prefer a single fraction. Okay?
Do which one?
Last second one?
Huh? Second last one.
Yeah.
Question 2.
Simplify question 2 part D. A2D. Yeah, don't want to waste much time for this. Okay, help you. Okay, there's something you don't remember. Plus or minus, okay? Plus or minus. Okay, this can help you to open brackets. And remember, when we copy, we don't think.
Okay.
When we think, we don't copy, okay? Otherwise, just stay there and waste time.
If root square equals to
Right is at root square first. Don't think. Right first, okay?